Let's do another example of using Hamilton's method to find the answers to an apportionment problem. Let's say in a fresh example, we have 5 departments at our university, and we want to give out 20 scholarships to the students in those departments. And now you could be thinking, well, how many scholarships should go to each department if we were trying to give them out? You could say, well, we have 5 departments, why don't we just give 4 to each? But as we can see from the populations of the amount of students in each of those departments, giving out 4 to each probably wouldn't be a fair division. And this is another example where apportionment can help us to give things out in a more fair manner. So to begin with, standard divisor, as always, which is, in this case, we have 800 total students and 20 total scholarships. So the standard divisor would be just the ratio of total population divided by number of objects, which would be 40, because the 0 would cancel, and 80 over 2 is 40. So that's math I can do without my calculator, finally. But that would be our standard divisor. And then moving from there, we need to take each state's population and divide by the standard quota. And actually notice this table is arranged horizontally as opposed to vertically. It doesn't really matter how you choose to organize them. I tend to like the vertical approach, but it doesn't really matter. Sorry. Okay, so I'm not implying that I'm bored with this, but this math can be a little bit tedious because it's just a bunch of different numbers. But I think you can see the value and the importance of apportionment. And as we look at further methods, the idea of fairness does come back into play. But basically, the biology standard quota will be 6.025. Business will be 6.75. Religion $3.65. Art should get 1.6. And then 80 divided by 40 is exactly 2. So that's one I can do, again, without a calculator. But basically, I could start with the standard quotas, which is found from the standard divisor. Under Hamilton's method, we're just going to round them all down. Start with the lower quota, find the total of the lower quota, which in that case, all of those add up to 18. And that would give us a surplus of 2 seats. So to find the surplus, just take the difference between the sum of the lower quotas and the initial apportionment amount. So you could think about add up each of LQ1 plus LQ2 plus LQ3, all the way through, and then do LQ and take that away from M, the number of objects. So M minus LQ to get the surplus. And then from there, we give out the surplus seats one at a time to the largest residue. So that would be business has the largest residue and religion has the second largest. So they would increase by 1, and all the other departments are going to get shafted and retain their original amount. And our final apportionment will be 20, and we're done. That would be our answer. So once you get the hang of apportionment, it's pretty straightforward. It's basically the same process every time. Well, there's different methods of doing it, and that's what we're going to get to in the next lecture as we wrap this one up. But basically, there's an ebb and a flow to these sorts of problems, and it all starts with the divisor and dividing and rounding. And there we go.